Okay, welcome everybody. I'm glad to see everybody is here. We've got a pretty good turnout. We've got a great co-host. I think it's his third or fourth role of co-hosting with us. The other ones were very popular. Got a lot of good feedback with Ray and some of the stuff that he's covered in the past. This is a topic that we've been getting some notes from folks saying, boy, we'd love a little bit more into the math channels and maybe a little bit of a deeper dive. We talk about them. We've showed you some pretty basic ones, but when we start to talk about deeper into math channels, it does become a little bit more complex, at least by visually thinking it is. And what we want to talk about here today is the power of some of these math channels. The title of this one, The Power of If and Other Math Functions in Ray Studio. But we also want to demystify it a bit. We want to show you that it's not nearly as difficult as what it looks when you first look at them. It can be a little overwhelming, and it still is to me as well. And so I always have to kind of slow down, stop, and my mind thinks the same way as Ray's does. He's going to show you how he breaks them down to make them where they're not as complex as what you might think they are. So looking forward to this. Pardon me, and I know a lot of folks that have been watching these have been looking forward to this type of a webinar as well. So we're going to talk a little deeper. And the other thing that I would like to talk about on the math channels as we kind of lead into this is while we're going to talk about the if statement, it's math channels in general, right? We're going to talk about one of them, how the power of it is, and Ray will get into touch off into some other ones as well. But the theory goes across all of the different types, right? The different functions that are in the math channels as well. As John Block mentioned in a previous webinar, the imagination is the only thing that's stopping you from using some of these to get even greater power out of your software and the data that you collect. So keep that in mind. And we'll talk about it a little more as we go, but I always tend to go look at the end result and say, okay, I see something in the squiggly lines, and I'd love to capture that in a quicker, easier way that is just nice and clear. I can push a button and it reports back of this thing that I've become concerned about, coasting or whatever it is, right? Time when you're not on full throttle or partial throttle, or what, every one of you is going to have a different need, a different desire for different things that you might want to see. So you dream it up, you think about it, you become inventive with it, and then you write the math channel around it so it gives it to you very, very quickly. So that's what we're going to talk about today. Yes, we're going to talk specifics about some specific examples to give you some ideas, but boy, don't be stuck on those examples only, right? Start to apply it towards the stuff that is important to you. Okay, perfect. So let's kind of get started with a quick introduction from Ray. I've known Ray for a little bit. I met him, I think, the first time when he attended one of my seminars at VIR, one of our on-site seminars. We chatted a little bit. We've talked back and forth on email quite a bit. Ray is a super valuable resource in this world for all of you that are out there. He does just a ton of work with user profiles and math channels, and to fit around the driver owner, or maybe even a little bit more focusing on the coaching side. But of course, anything he's coaching it works for those of you that may not use a coach but try to coach yourself. So keep that in mind. Ray, give us just a little bit of background on you and what you've done and how you've gotten here, and then we'll jump into the power of if.
All right. First, I'm honored to be co-hosting the 40th one of these things. That's pretty amazing. And honored to be following up John Block, because truthfully, John has probably taught me most of what I know. So when I was racing, I actually hired John to be my data guy, and just working with him, I learned a ton.
I did not know that. Interesting tie there. I did not know that part. Good.
Yeah.
Very cool.
So I've been involved in motorsports since 1994, and actually today I was thinking back, from 94 to 97, I was just basically a crew guy for somebody who was racing a Formula V, and just really had the passion for motorsports and wanted to learn. Well, back then there was really no data system, so I was actually doing stuff in Excel, tracking lap reports and tire pressures and anything else. So I actually started with data before data became popular in club racing. So So anyway, when loggers and all started coming out, I think I had a AIM Micron Gold, and I just immediately saw how powerful it was to be able to get more information out of the data system, and it helps you figure out how to go faster. Whether that's doing something with car setup, or driving differently, or whatever. So anyway, my company is Precision Driving Analytics, and I started that in 2015. Um, and I've had a lot of fun doing it. I really love helping people go faster and looking at the data. I've got a simulator at my house. I'm studying data from that. I'm studying data from real cars. I'm just constantly looking at this stuff.
Perfect, and constantly helping people that need help as well. So we'll talk a little bit more about it as we go a little bit. But Ray does a lot of these math channels and profiles for individuals. These math channels, they're very, very specific to your data channels, right? What you've named them. You can't just put throttle in if you've called it TPS, right? So these things need to be tweaked a little bit to fit your data files and your data channels. So that's a thing that Ray does quite a bit, and also the John Block webinars that we talked about on the Tuesday series. So if you're interested in those as well, so perfect. Given Ray remote control here, let me click once here on this. Let's get it to There we go. Did I go two? Let me see. I think I'm right. Okay, Ray, you got control of the mouse. Let's do a quick introduction into the if statement and why is it so powerful. You go ahead and take over, and let's talk about it a little bit.
All right. So in my last webinar, I touched upon a few math channels that I use a lot: the integral functions, the derivative functions, and I even showed a couple of if statements. And I kind of did that all pretty quickly. So I thought this would be a good topic to dive in a little bit deeper. And, I really started thinking about it, what do I use a lot? Well, I use the if statement a lot, and why is it so powerful? It's because the if statement / function, whatever you want to call it, gives you the ability to compartmentalize your data into smaller pieces. And once you do that, this in turn gives you the ability to work with only those smaller pieces of data. And that allows you to quickly identify the solutions or issues that are of interest to you. So it's really just a great way of funneling your data down into smaller pieces that can give you good information. And that's the whole point of looking at data, right?
Exactly, especially the math channels. It's really filtering it down in even faster than just the data.
Right. So there's other mathematical functions, logical functions that are usually used with if statements, and these are them right here. And Roger brought up where they would be in the math channels window. But there's greater than or equal to, less than or equal to, and not equal to. All pretty straightforward, right?
Work almost exactly the same way as the if, just doing different things with the data, obviously.
Right. All right. So, what comprises an if statement? Well, an if statement has to have three arguments. That's the first thing to know. That first argument is a logical test. And if that test is true, then that's your second argument. And if it's false, that's your third argument. Okay. And that is true all the time. Okay. In algebra, you may have seen if statements, and they would be written in this manner. You have an if and a paren, and if x is greater than y, then you get a as your true value, and b would be your false value, and then you end the parentheses. Well, AIM is basically doing the same thing. They just have a little bit of different syntax. So this formula here is exactly the same as this one as far as the results. So now we have the greater than first, and read it the same way. If x is greater than y, then return A, otherwise return B. So once you understand these functions, it makes life a lot easier. All right, so last time when I spoke, I talked about coasting. And again, I kind of breezed through it. So um, before you create a math channel, you have to know, what your end goal is. So I've kind of written out the definition of coasting in my mind and how I'm going to get there. So I'm defining coasting as if the driver is not using the brake or the throttle, then identify this situation as coasting. And you notice I've got some different colors here. All my math channels are going to be in this bright blue, italicized. The first level if statements, we're going to get down to lower level if statements, are always going to be red. And down here, the hardwired channels are going to be in this different color blue. I don't know what you call that. The functions are going to be in this green color, and the results are going to be in bold black. So in order to get to coasting, I've got to come up with two other math channels. I'm going to come up with a no brake, and that's simply going to be if the brake pressure is less than 50 psi, then return a 1, otherwise return a 0. And the reason why I'm using 50 is because down at the bottom of your sensors, you could have some fluctuation there. So it just basically assures that, the driver is off the brake. And no throttle is going to be, if the throttle is less than 10%, then return a 1, otherwise return a 0. And using 10% for the same reason, there's some movement down at the bottom of a lot of sensors. So it just kind of alleviates that.
It's
So go ahead.
Yeah, what's interesting about this is when you as all of you users that are going to go out and build these, and me when I'm building mine, maybe 50 psi is not what you're after. That's what's so cool about all of the different math channels is maybe it's a smaller number, maybe it's a bigger number that works for you. Often we build them the way that folks like Ray build them, and then you look at the data, and which we're going to do here, and then you start to adjust, right, and to get the results that you're after for your car, your track, different things make it work that way. The only other thing I'd like to make sure we mention here real quickly is there's we have shared a lot of math channels here from AIM. People have written me emails. I've talked about them a lot in the webinars, and those had a coasting channel in them as well. Again, this shows the power of what we're doing. You can do these things in different ways. The ones that we've shared with you guys, and I see somebody in the chat box talked about you've included the coasting in your data. That's pretty cool. We include a cornering force as another if statement in the coasting, which in this case, for what Ray was trying to accomplish, he did not use that. So don't get confused with that. It's just, again, the power of the math channel where you put into it what you're after and what you want to get out. So keep that in mind. The Robinson, perfect. I was just going to mention that Robinson taken over for the traveling Robbie. Robbie is just made it. You can see, but he is traveling, so links are a little hard. So the able Robinson is taking over on the linking duties. He put up a math channel box. I'm sorry, a math channel document link in the chat box. Michael mentioned that he was looking for some documentation stuff. So there that is. There is another one that Robinson will link in a second that is a piece of the Race Studio 2 analysis, the math channel part of that one that Robinson will link up in there as well. So perfect. Then we'll go. You were probably just about ready to go to the next slide, I suppose, Ray.
Almost.
Okay.
And actually, sometimes I do add that some lateral G if statement in there. I think it's actually valuable to look at both coasting with it and without it. Because some coasting is actually beneficial. If you're waiting for those front tires to have grip, you don't really want to highlight the coasting there because you've got lateral G's built up and you're just reducing understeer for that little bit of time. But in this case, I'm not taking that into account. My coasting math channel is going to be if no brake plus no throttle is equal to 2, since each one would return a 1, then return a 1, otherwise return a 0. And I think Andy asked a question, can it return a null value? And the answer is no. AIM does not have the ability to return a null value.
We work around that, Andy, in the software, in some of our statements in the software, in the channel reports and other things. We can not, average average when 0 equals null. So there's some ways around that, but we do not handle that in the math channel side.
All right. All right. So here I'm just writing out the math channels themselves. No break is simply if brake pressure is less than 50. And again, I'm using the aim syntax. You have the less than in green and the end parentheses in green. If it's less than 50, then return a 1. Otherwise, return a 0. No throttle, same as what we wrote out. If throttle percent is less than, oh, sorry. Oh, that should be a less than. Is less than 10, return a 1. Otherwise, return a 0. So yeah, we need to, should have caught that, Roger.
I knew it was my fault. We will fix this. By the way, just so everybody knows, there is we do have, and Robinson will probably link it here in just a second, but it'll be fixed for the link in the description box, this particular one. But we do have the PowerPoint presentation that he's going through. It's going to be more important on this one than many of them because of a lot of cool stuff that he's doing here by breaking down the math channels. Robinson can link that. Yeah, we got a little bit of a problem there. You may want to re-download it later, but if you want to open it up and have it going right now, you can do that. The PowerPoint presentation will be linked in the chat box here in just a second. There it is right there. So we will fix that one.
Yeah. All right. So going with what I wrote on the previous slide, if no brake plus no throttle equals 2, then return a 1, otherwise a 0. And since it's starting to get a little bit more complicated, I decided to underline in red the 3 arguments. So this long one is the first argument, and then you have the 1 as your true argument and the 0 as your false argument. So that's the 3. But let's say you didn't want to create these 2 other math channels, no brake and no throttle. Well, you could do all this in one if statement. So if brake pressure is less than 50, and if throttle percent is less than 10, again, this should be less than, then return a 1, otherwise return a 0. So now we have a nested if statement, and that's in purple here. So the 3 arguments for that are simple. It's just right in the row. The first one's here, second one's here, third one's here. But now, since it's a nested if statement, the top level if statement, the arguments are, the first one with the less than, but now your second if statement is your second argument, and then the 0 at the end is your third. And the reason why I've underlined these 2 zeros is because when you're writing these things, you have to have as many zeros at the end as you do if statements. So that comma, 0, paren, if you have 2 if statements, then you have 2 of those at the end, okay? And if you remember that, it makes life a lot easier, because you start making these things bigger and they start getting a little bit more confusing.
This slide is just perfect to me. It is the problem that I had when I first started using math channels, and it's the problem that I still fight a little bit. And Ray has made this very, very clear and interesting, not only with the colors of the brackets that he's used here, but also those underlines. But take a little time and think about, and we're going to get into some more complex ones he's going to show in a minute, doing the same technique of showing you where these 3 arguments are underneath these different functions, and the red line here and the purple line. And that's where it's going to manifest it to you is you're going to build one of these and you're going to click on the test equation, test the formula button, and it's going to come up and say that it's missing a bracket, or a closed bracket, or missing a constant or something. And right. And him doing this will make this take some of the black magic out of this and say, okay, I see how it's broken down and what it wants, and we're missing a 0 at the end or something, right? So keep that in mind. This is these slides that he's about to show you will make your life a whole lot easier if you're new to the and experienced with these math channels.
Right. A couple questions here, Eldon. I do think I answered your question in that sometimes I do use lateral G's in these cosine equations. Is there an and or function or function in aim? Not really with the if statements. There's a couple of other functions that you can use, bit and bit or. I like the if statements because I can understand the logic a little bit better. but but I do use those sometimes as well. Maybe if we have time at the end, we can go into those too.
And Neil, some of those too, those Robinson, if you scroll back up in the chat box, Robinson leaked a math channel document or two. They are those the rest of the functions are all listed in there, and some of the different things, including the bit and in bit or.
All right, so now that we've defined coasting, and in my last presentation, I think the coasting math channel was handed out. But let's say we want to look at lifting, where well, there's several different definitions, and it's really up to you to come up with your definition. I came up with three right off the bat. So the three that I've come up with is if the driver is lifting off the throttle, then identify the situation as lifting. So if he's off the throttle, he's lifting, period. If the driver, the second one is if the driver is lifting off the throttle and not using the brakes, then identify the situation as lifting. So I want to take away when he's simply just braking the car. And my third one is if the driver is lifting off the throttle and not using the brakes, and the throttle percent is greater than 30%, then identify the situation as lifting. So each one of these is narrowing it down just a little bit more, okay? And it all depends on what I want to get out of this, this equation. So this slide is kind of trying to represent what's in my mind as to what I want to capture, okay? In the green, we have a throttle, and in the red, we have longitudinal Gs. So you can see clearly there's a big lift right here, and the driver actually has to be, or happens to be, over 50% throttle. And if we look at the longitudinal Gs, well, you know, on the positive side of zero, that's acceleration, and on the negative side, that's deceleration. So you can see that the acceleration stays positive because the driver is still giving some throttle, okay? So in my mind, this is what I want to capture, okay? Obviously, not all these if statements are gonna, they're all gonna capture that, but some are gonna be more narrow than others, okay? So here's lifting one spelled out. Pretty simple. If throttle percent is, I'm using 95, less than 95%, then return a 1, otherwise return a 0. Lifting 2, if throttle percent is less than 95 and the brake pressure is less than 50, then return a 1, otherwise return a 0. And notice I'm not really identifying the 0 on the end. Those are basically just a requirement to meet the three arguments. Once the formula gets to this 0, it's done, okay? Now lifting 3, now we have, you can see we have two nested if statements. So if the throttle percent is less than 95 and the brake pressure is less than 50 and the throttle percent is greater than 30, then return a 1, otherwise return a 0.
Let me add something in for the question with Andy. I think you might have been just going there looking at your eyes as you were talking. He talks about, Andy has a question, do we always need to end in a 0, or could we end in something else? The 0 is, ending in a 0 is not the mandatory thing. It just brings the data trace to a 0. And the reason that we do that, for the most part, the reason at least I do, is because in the software, again, like I mentioned a little bit ago, we can say 0 equals null, and then we can do some averaging and take those zeros out, right? But I've seen a lot of other users that because of scaling and some other things, maybe the values are normally at 2,000. You don't want it to always drop to 0. Maybe you want it to drop to to 5,000, or go up to 5,000, or drop to 25, or drop to another math channel value, or a hard sensor value. That 0 is just what that channel is going to do if all of this stuff if it doesn't meet these criteria. So.
Right. Yeah, that's absolutely true.
Hopefully everybody understands that. 0, while it's a placeholder there, and almost always we use 0, it can be something else if you want the end value to be something else.
Yeah.
Okay.
All right. So, and yeah, there are circumstances where I won't use the 0. I'll use something like 1,000 or whatever. Yeah. I want it to go the other direction.
but it's rare. Almost always 0 is probably going to work for most of you.
Right. All right, so lifting 3, you can see I drew some more lines here. So let's start at the lowest level. This one's in orange. Pretty simple. Here's our 3 arguments. The first one is just the greater than function. Second one is that 1. Third one is that 0. Just like the coasting, where we had 2 if statements, same thing here. First one is in purple. Now that second if statement is your second argument in purple, and that 0 in the middle, second from the end, is your third argument. And now the top level if statement, again, still has 3 arguments. The first one is just the less than function. Now the 2 if statements are your second function, or second argument rather, and then that last 0 is your third argument. So if you keep that in mind, it makes life a little bit easier when writing these things.
Very much so.
All right. So at this point, Roger, I'd like to jump into AIM.
Oh, I got to go to work. Jeez. Yeah. Let me have the mouse there. Then I will share this, a new share, and we will jump into the AIM software. And make sure you click once, and you're off and running.
All right. All right. So I created a profile here called Lifting. And again, if you haven't seen John Block's webinar, he stresses the importance of creating user profiles. You can see, I created these in advance, and all it takes is a couple of clicks to bring it up. So
and Robbie will, Robinson will put the link to that if you missed it. He'll put the link into the chat box.
All right. So and my math channels, you can see that I've created lifting 1, 2, and 3. So again, just exactly how we had it in the presentation. And what's being shown is lifting 1, and I can show you that by coming over here. So that's the measure that's highlighted or checked, and all of these ones are basically lifting by that definition. So you can see it's capturing when the driver's on the brakes. It's capturing everywhere where that driver is off throttle. Okay, even this little lift here. Okay, so that gives us some information. It's a little bit too broad for me. Okay, so let's see what lifting 3 looks like. Again, we'll look at the math channel. Whoops, I didn't do it. Okay. Lifting 2, again, we're just adding in the brake pressure being less than 50. And you can see now when he's on the brake pressure, I no longer have that lifting showing up as a 1. Okay. So everywhere he's on the brakes, it's no longer showing up. So now I've narrowed it down just a little bit more. I still want to go further. So let's look at lifting 3. And again, we'll look at the math channel. All right, so now we have the throttle less than 95, the brake pressure less than 50, and the throttle greater than 30, okay? So you can see each time we've done it, we've gotten less and less lines. So, this is one of the areas that I wanted to capture, right? I can see a big lift there, and that's a nice solid line where that driver is greater than 30% throttle, but off the throttle. So maybe there's a good reason for that. Maybe there's not, but it allows me to see it, right away.
Perfect.
But what is the driver really doing when he's lifting? He's physically lifting off the throttle, right? Well, the last time I spoke, I also talked about throttle velocity, and let's pull up that channel. And all this channel is a derivative of the throttle position sensor, okay? So it's the rate of change that throttle pedal is going through, okay? So anything positive is the driver applying throttle, and anything negative is the driver lifting off the throttle. So why don't we add this into the equation? Let's say I just want to capture where he's lifting off the throttle, but I want to keep all these other parameters in place. So I'm going to do something very daring, and I'm going to try to create a math channel live in a webinar.
While you're starting that process, I did see a question come up and talked about looking for an example of, boy, narrowing down a specific part of the track and getting data just from that. Whoever asked that question, you're going to see an example of that here in just a couple of minutes. So keep that in mind. Keep watching.
Stay tuned.
He just built lifting 4, so he's going to fine tune this even more. And he's important over in the channel parameters is to set those up so the channel looks right. And that's all a bunch of scaling and naming and some other things. And but important to do those as well.
All right. So since I already have lifting 3 with 3 of the parameters that I want to use, I'm just going to copy this math channel and I'm going to place it into my lifting 4 math channel.
Because really what you're doing is adding to one that you've already done, adding another parameter, nesting in another one.
Right. So the area that I want to replace is the 1, right? That's my true statement. So now I want to go through another if statement before getting to another true statement or true value. So I'm going to just delete this and I'm going to say if, and I want to say less than. And you can use the functions over here on the right. It's just easier for me to write it sometimes. And I'm going to choose throttle velocity, which is a math channel here. And I'm going to double click that.
Stick this right in there for you.
And it's less than 0. Whoops, 0. And in parentheses. Then I want to return a 1. Otherwise, I want to return a 0. And I'm going to put some spaces. It really doesn't matter if you have spaces or not, but it's a little bit easier to see if you have some spaces in between the commas and your values. So here's a true test. So I'm going to hit test channel and hopefully it comes out good. If not, then I'm going to have to figure out why not. All right, it works. So good. So now I can just hit OK. And I can come back here and choose lifting 4. And I'm going to move that down into the 3rd thing. But now you see it's a much more narrow focus and probably captures a little bit more of what I'm truly looking for, okay? Even though I'm not capturing the entire lift, I'm capturing the important part where the driver physically lifts off the throttle, right? So what can you do with this? Well, one thing you could do is you could look at a track report. I have one here. If you don't know how to create one of these, you just need to come over to View and then Track Report, and it'll pop one up. I'm just right-clicking, and that brings up my my window to make changes. And I'm going to change this to lifting 4. And I'm going to change this to lifting 4, and I just I'm in that habit. I don't know why. It's showing a max, which for battery, that doesn't mean anything to me. So I unselected that. I'm going to say OK. So now I can look at this and say, oh yeah, okay, going up the S's at VIR here, the driver is lifting, and whether or not he's doing that because the car setup is not allowing him to be at full throttle, or if it's something that we just need to work on with his driving, it tells me right away that, that he's lifting there, and he's lifting through here too. And there's kind of a pattern anywhere where there's a pretty significant turn, I'll say, there's some lifting there, so maybe the car has too much understeer or whatever, so what else can you do with this? Well, you can create a total lifting channel, okay? And that kind of helps you also narrow down whether or not improvements have been made. So you can look at it visually on a track map, or you can come over here and create another math channel. And I'm going to call this one total lifting. And, I haven't, well, I've created it before I started the presentation, but, the first time you do any of these total channels, you kind of have to guess as to what the full scale is going to be. I know it's not going to be less than 0 though, so that's going to be my minimum. So in order to get to a total, what I want to use, and I want to do it per lap, is I want to use a lap integral. And
right at the bottom, there you go.
Yep. So you can double click on that. And if you click on the test channel, it just happens to highlight that. So then you can come over here and find your lifting 4 is what I want. And Roger, if you see it, let me know.
There you go. Just went past it. Right,
Yeah.
right there. Sometimes
And
you get so many of them, it can end up being looking for the needle in the haystack.
right. All right. So all I did was double click on it and it put it in and click the test channel and it's all good. So click OK. And now let's just go back to our measures graph and add that total lifting in there. So now at the top here, we have the line. You can see every time that he lifts, that line is getting bigger, right? It's going up higher. So let's just compare that to another lap. So it doesn't really matter which one I choose. I'm going to choose this 205. And if I pick per lap color, then I can see, okay, this area, and I can't see because I got these videos in my left.
Got his zoom components are in his way.
Yeah.
Oh, well.
So anyway, the total lifting is 8.9 there with the yellow and 5.8 with the red. So the red happens to be the slower lap. So lifting was not the issue there, right? But it's still valuable because it still identified what I needed to know. But that is a quick way of comparing, especially if you've made setup changes or something like that, just working on a specific area. I use that the lap integral function a lot for that type of thing.
Couple of comments that came in the chat box, which I know you're probably not following along as well. But the number one question was, the latest one was 5.8 what? And it's seconds. It's seconds that lifting 4 was happening. That's what lap integral does. Is it adds up the number of seconds that something happened, then it resets to 0 at the end of a lap. So that's what that is, Michael. And the other one was kind of an interesting one that I just something to chew on. Another way to filter out. It was Joe. By adding a gear math channel, I can see what lifts are attributing to the gear changes. So put another if statement or equal to or whatever, and that using your gear channel, and that'll take even filter down even more and get rid of the gear channel size of it. Great imagination on ways to continue to filter this down so you're getting just what you're after. So thank you, Joe, for adding that. That's a good idea.
Roger, maybe you can answer this one. Truthfully, I don't know. Eric asked the question, can you add new lines and blanks to your liking to the formula as that would help the reading?
Yeah, my experience with that is it's been not terribly powerful that way. Emiliano in the background can maybe even add to that even a little bit more in the chat box. But what I have found is, yes, I can put a break in there, but it treats it as just a single one. But if you put an enter or different things like that, the blanks will work fine, spaces will work okay, but the new line isn't something that I think works well in this.
Right. And by the way, for presentation purposes, my settings for these measure graphs are, I'm sorry, I got the line set at 2.
Yeah. And
normally I look at these things with 1, and you can just see the difference here.
That's easier to see. Yeah.
Easier, but for presentation purposes, I make them a little bit wider. But if I'm analyzing data, I'm also always use 1 as my my line width.
Yeah. Grant, your example is next. The one that you've asked for a couple times, and somebody else asked for it as well. It's our next example.
All right. So Roger, can we go back to the PowerPoint?
I sure can. Let go of the mouse. There we go. New share PowerPoint. There you go.
All right. Oops, I got to click first. All right. All right. So somebody asked about this. So another very powerful use of the if statement is to identify a track segment using distance. Okay. And I talked about distance last time as well. Distance is simply, it's the lap integral because I want to look at it over a given lap of GPS speed in miles an hour, divided by 3,600 to get that to seconds, and multiply by 5280 to get it to feet. Okay. So if the starting point of a segment is greater than X number of feet and the ending point is less than Y number of feet, then define this segment as Z. Okay, so that's the if statement written out. So my Z in this case is going to be the VIR back straight. Okay, and I've already looked at it. The distance I want to capture is if it's greater than 10,600 feet and less than 12,500 feet. So if it's between those two measurements, then return a 1, otherwise return a 0. Okay. And Roger, I hate to do this to you, but let's get back to aim.
No, I can do it. There you go. Click once and you're off and running.
All right. All right. So created a VIR back straight profile, and I'm going to uncheck one of these laps here. All right, so here we have throttle, RPMs, throttle down here, RPMs, and then speed at the top. And I've created one math channel, and I called it VIR back straight.
Pause just a second. Tice, this, I did see the word geofencing before, and geofencing, most people would consider that to be like a GPS bracketing out an area, right? We can't do that here. So our workaround to that is this distancing, rollout distance sense, so you can pick certain spots of the track. One of the things that Ray offers as a service is you send him one of your data files. He already has a lot of the tracks made up, but then he breaks down these tracks into these segments, and then you can do all of these things, based on different map segments or track segments, just like he's about to build right here, right now. Just like he built with that first channel, and now he's going to apply a math function against it. So right. Go ahead, Ray.
And I have tried really hard to get the geofencing to work, but I have not. So anyway, so now we have our math channel, VIR back straight, and exactly how I wrote it in the presentation: greater than 10,600 feet, less than 12,500 feet. So let's see what that looks like. VIR back straight here. So one reason why I chose 10,600 is because I want to start where the driver's at full throttle, okay? And the interesting thing is that it has a shift in the middle of this, or close to the middle, and it ends before the driver gets on the brakes. And one reason why I want to do that is because I'm just looking for power, basically, whether that's due to how quickly shifting, or the draft, or anything like that. So, and I'll show you how I do that. So, power is going to show up in longitudinal acceleration. So, if I create a math channel that just captures longitudinal acceleration for that area, it's going to look like this. If the VIR back straight is equal to 1, then return
geofencing out an area. Is that first part of the equation?
Return longitudinal acceleration, and I just happen to use the GPS version of that. Otherwise, return a 0. So let's see what that looks like in the measures graph. That's here. So it's simply, you can see it's only going to be in this area. And it's simply your longitudinal acceleration. Notice how it's going up and down, and there is some slope changes on the VIR back straight, so that's part of it, but part of it is the shift. So let's just pull up a few more laps here, a couple more, and I'm going to do the per lap colors. All right, I'm going to change this yellow to a blue or something that we can see a little bit better. How about purple? All right. So, I can see that there's some differences here, and I can zoom in on it. I'm going to use the magnifying glass. So yeah, there's some differences in where the driver is shifting. I can see there's some variances here at the end. As far as acceleration, you can see 0.14 versus 0.11 and 0.11. But you know, it's still not really giving me what I really want. It's pretty hard to understand what this is really telling me. So wonder if I use that lap integral function again and add up the acceleration. So let's create that math channel. I'm going to go to the end. I'm just going to do insert, and I'm not very creative, so I'm just going to call it VIR, sorry, BS, oops, BS Excel 2. Say okay. And my scale is going to be 1 and 0. So I can do the lap integral and pull up the math channel, or I can do the copy and then do the lap integral around that. So either way will work. We'll do it this way. And I'm just going to put lap integral at the beginning and underscore 9TG. And we'll test it. Okay, we're good. All right, so now I just need to find that math channel. There it is. All right, so now it becomes a little bit clearer. And actually what I'm going to do is I'm going to change the line to 1, so it's a little bit more apparent. Hopefully everybody can see it okay. All right, so starting out, if I look at the speed here, which is at the very top, the the green and the red laps are actually equal in speed. The fastest lap is actually the slowest at 109.5. So let's go a little bit further. Speeds 115.9. The green lap is actually the fastest. Red is second fastest, and purple is still the slowest. Let's jump to where the shifting is. Okay. Now the green lap is the slowest, sorry, not the slowest, second slowest at 117.6. Red is now the fastest, and purple is still the slowest. And you can see that our accelerations are different as well. The purple, the fastest lap, actually has the highest total acceleration here. Red is second, and green is third. So clearly shifting made a difference, and I'm going to zoom in a little bit further on these shifting points. So you can see that the driver took longer to shift, which is what affected his acceleration and his speed, okay? The other ones, actually purple's a little bit faster than the red, but that's one factor, and maybe that's something I want to work on with the driver. All right, but let's continue on. All right, so we're a little bit further along in the segment. The accelerations, again, the purple is the fastest or highest total acceleration at 0.65, and then 0.64 and 0.63. Speeds, about the same, 121.5 for the green, 121.6 for the red, and 121.4 for the purple. Again, purple is the slowest, and that's our fastest lap. So now you can see the purple is gaining steam, right? That total acceleration is now 0.73 against the red's 0.69 and the green's 0.66. And what do you know? The speed is now the highest for that purple line, 123 versus 122.8 versus 122.3. So the green started out being the fastest, but now the purple, which was the slowest, is now the fastest. So clearly something happened in this segment that caused this. And I know that drafting is huge at VIR. I know it wasn't the shift that caused it. So my assumption here is that the driver was in a draft, and that's how much it affected his speed. It brought up his total acceleration, and it brought up his speed. So so anyway, that's just one of many things you can do with this stuff. Really, your imagination is your only limit. Um, so anyway, that's what I got for you.
One kind of a cool thing that, to tie this all kind of back to, we were talking earlier about the following zero, and you could use any value you wanted there. One of the
Right.
reasons we're using that zero is in this particular case here, we have that this acceleration 2 channel. All this is doing is adding up the amount of acceleration that has happened in between these two, geofenced areas, these two areas of this part of the straightaway. If you were to be doing zero, right, the lap integral would be counting all of the acceleration values even before this geofenced area, right? Because when we have zero, of course, the lap integral is not adding all of that. So if you were to use a false number of 20 or 0.2 or something to keep it off the bottom of your screen, which I seen in one of the chats there, you would have been adding this lap integral value up all the way. And then this number over on this end of it, where we're looking at the total amount of acceleration that happened in this area, trying to find that those draftings or those pushings or the whatever we're looking for, this number wouldn't be as accurate as it is with the zero as part of that. So little things like this are just powerful tools that, again, your imagination is the key to making this work for you, right? So you could
Yeah.
even write up how what is the distance of this piece here, because we have that distance channel that you wrote, Ray, that we're starting it here
Yeah.
to here. We could actually count that and put that together and have a distance. I seen another question in there. Well, how about the amount of time it took the driver to get in that thing? You could do it in a split report, but you could also do it right here by creating a time function. We have the ability to create a distance function and a time function, and we could just add up the time that the driver was in between these two distances, and add that as another part of additional math channels, or a standalone end result that what you're after as well. So again, your
Yeah.
imagination. What do you want to do? Contact Ray, contact me. We can chat about maybe some of the different things, some of the different ideas you have. It's some pretty fun stuff that can be done here. It's pretty powerful. You have anything
Yeah.
else to add there, Ray, before we run back into the PowerPoint?
No, just I think that's it actually. Like I said, it's just your imagination that limits you, and it's amazing how many things I think of at 2 o'clock in the morning when I'm trying to solve a problem. How do I write that math channel to get to this answer? And sometimes it's easier to write several math channels to get to the result you want. But it's all in how you do it. But hopefully this helps you see that it's not as difficult as it looks when you're looking at a very long math channel.
Exactly. You come up with ways to make your time is of such an essence at the track that, boy, some of these math channels and profiles and all these different things that John talked about and that you specialize in, make that time that you're at the track in between sessions be used so much more effectively, and that's so critical. Perfect. The to kind of start to close this one up, that we have this video here, this recorded webinar will be within an hour or so, will be up on our YouTube site. It'll be our 107th video that we have up there. All of our 40 webinars that we've done are all recorded and up there, plus many more. So keep that in mind. Go visit our YouTube site, check out all the different stuff that's there. There's just a ton of information there. So take a look. Customer support, we're always out there. We're customers and dealers and folks like Ray are a big part of our customer support as well, and we look forward to helping you in any way we can. We normally have a really full crew here in the background, but today Robbie came in for a little bit, but he's traveling. Cameron is at the Indy 500 working with our SmartyCam program with IndyCar and all their other series. And Brick is on the way to a track. We have Robinson here. He's kind of holding down the Roanoke office. He probably is going to travel, maybe a Saturday to something a little more local that way. So we haven't had all of our full crew here, but the guys that are here, Robinson and Emiliano, have done a good job in working with you in the background. So but we're hitting all the tracks. Give us a call, emails, see us at the track, do anything we can. Look forward to it. So the next one that we're going to do next Tuesday, we've had just really good feedback from Eric's previous webinars that he's done with us. We've talked about karting, downloading the data. What do you kind of take a look at? But we've got a lot of feedback, and it's going to tie together with a lot of the guys that are here with the cars, car stuff. We're going to talk about maybe some additional sensors and some other things on karting, and maybe some different math channels and different ways of stitching all that together. Of course, data analysis, it really does run across the different platforms that you might use. Boy, if you're a sports car guy or a dirt oval or an off-road racer, some of the tools that we're talking about here will absolutely cross over. And Eric's got some ideas that we're going to talk about on Tuesday for the next one. It's going to be a good time, a bit of a more advanced karting data analysis where we use pedal position sensors and do some maths and some other things and figure out some kind of cool ways of looking at karting data. So look forward to seeing everybody on next Tuesday on the 18th and talk about that one. Again, thank you, Ray, for coming and doing this. There's some information, contact information for Ray, the name of his company and his email address, of course. I know it takes a lot of time to prepare for these things, and and we do appreciate it very much, Ray. Again, this is your third or fourth one, so you know the drill, I suppose. It's and the deeper we go, the more you want to prepare and do even more. So we very much appreciate it. Thanks to all the AIM guys that are in the background. And Ray, is there anything else kind of closing up? Is there anything else you'd like to add, or maybe think about start thinking about maybe feeding Ray some information on future webinars? You got anything you have in mind for the next one? Put you on the spot.
I can go much deeper with math channels for me and the stuff that I get out of them for sure. I mean, to me, that's a huge area that's mostly unexplored by most users. So yeah, I mean, to me, I couldn't live without those and the user profiles, so if you're not using this stuff, then you're not getting everything out of the system you paid good money for. So
Exactly. And what I love about what Ray does for us and everybody that's still listening as we're kind of on our way out, Ray does these things, and he's not just coming up here like with a professor's hat on and telling you how the function works. He's using them in real life examples, which should give you some more ideas and really start to get that imagination flowing on what you can do with math channels as well. So again, thank you, Ray. Thank you to everybody that attended. Thank you to all of our guys in the background that have been answering your questions. The questions and answers will be up in the description box that we've answered either live or typed in the answers. The data, the profiles and the math channels that Ray used here today will be in the YouTube description box link in about an hour, ready for you to download this sample data and his math channels and his profiles if you want to use those as jumping off points for your own. So all of that will be up there as well. And again, the presentation with a couple of typos fixed that Ray and I will talk about here in just a moment. And we'll get that up there and ready for you as well. Thanks everybody for coming. I appreciate it and look forward to seeing you at the next one. Talk to you soon.
Bye, everyone.